The Big Bang is a scientific theory that describes the origin and early development of the universe. According to this theory, the universe began as an extremely hot, dense, and compact state, approximately 13.8 billion years ago. It represents the prevailing scientific explanation for the observed expansion of the universe and many other cosmological phenomena. In this video, we will unveil 6 intriguing theories proposed by scientists and cosmologists about what may exist beyond what we can currently see. Mirror or symmetric universes. The concept of mirror or symmetric universes, also known as parallel universes or the multiverse, suggests the existence of other universes that mirror our own but exhibit slight variations in physical laws, constants, or initial conditions. While this idea has gained popularity in science fiction, it is important to note that it remains largely speculative within the realm of theoretical physics and cosmology. The motivation behind the concept of mirror or symmetric universes stems from the desire to explain the fine-tuning of our universe's physical parameters. The observed values of fundamental constants, such as the strength of gravity or the electromagnetic force, seem to be finely tuned to allow for the emergence of life. The existence of other universes with different values of these constants could potentially provide an explanation for why our universe appears to be finely tuned. In certain theoretical frameworks, such as inflationary cosmology or string theory, the existence of multiple universes is proposed. These universes may have emerged from a cosmic inflationary phase, or through the complex geometry of higher dimensional space. Within this multiverse, different regions or pocket universes can have varying physical properties, giving rise to the notion of mirror or symmetric universes. The variations between these universes could manifest as differences in particle masses, forces, or even the number of spatial dimensions. Some versions of the multiverse theory suggest that each universe represents a different solution to the fundamental equations of physics, resulting in diverse physical laws and properties. It's important to note that concrete empirical evidence for the existence of mirror or symmetric universes is currently lacking. These concepts remain highly speculative and are subject to ongoing scientific research and debate. While there are theoretical frameworks that support the existence of a multiverse, direct observational confirmation or detection of these parallel universes is challenging as they may exist beyond our reach of observation. Bubble universes. The concept of bubble universes is an intriguing idea that arises within the framework of certain cosmological models and theories, such as eternal inflation and the multiverse hypothesis. It suggests that our universe is just one among many bubbles that exist within a larger cosmic structure. In the context of eternal inflation, the universe is thought to have undergone a period of rapid expansion shortly after the Big Bang, resulting in the production of new regions or bubbles of space-time. Each bubble represents a separate universe with its own set of physical laws, constants, and initial conditions. These bubbles can be thought of as separate entities or domains within a vast cosmic foam. According to this concept, each bubble universe could have different physical properties, fundamental forces, or particle content. The variations in these properties among the different bubble universes would give rise to a multiverse, where an ensemble of diverse universes coexist. The idea of bubble universes attempts to address questions regarding the fine-tuning of our universe's physical parameters and the observed large-scale cosmic structure. It suggests that the properties of our universe, including the values of fundamental constants, may simply be a result of the specific conditions within our bubble, while other bubbles may have different physical characteristics. However, it's important to note that while the concept of bubble universes is an active area of research, direct observational evidence for the existence of these bubbles is currently lacking. Since these bubble universes would be causally disconnected from each other, making direct contact or observation of other bubbles extremely challenging. Scientists explore the concept of bubble universes through mathematical models, computer simulations, and theoretical frameworks such as inflationary cosmology and string theory. These models provide a theoretical framework for understanding the possibility of a multiverse composed of a vast number of bubble universes. Quantum foam realities. The concept of quantum foam realities is rooted in the field of quantum mechanics and explores the nature of space-time at extremely small scales. It suggests that beyond the observable universe, the fabric of space-time is not smooth, but rather composed of a dynamic and turbulent quantum foam. In quantum mechanics, the uncertainty principle states that there are inherent limitations in our ability to simultaneously measure certain pairs of physical properties with high precision, such as position and momentum. This principle also applies to the fluctuations and uncertainty associated with the fabric of space-time itself. According to the concept of quantum foam, at the smallest scales of space-time, there is a fundamental granularity or foamy nature that arises due to these quantum fluctuations. This foam-like structure is characterized by the constant creation and annihilation of virtual particles and fluctuations in energy and space-time geometry. The quantum foam is envisioned as a highly dynamic and turbulent sea of virtual particles and fluctuations, constantly popping in and out of existence. These fluctuations can affect the geometry and properties of space-time, giving rise to a multitude of possible realities and potential outcomes. In this view, the quantum foam is seen as a fertile ground for the emergence of diverse quantum states and alternative histories. It suggests that beyond our observable universe, there could be a vast array of fluctuating realities and possibilities, each associated with different configurations of quantum foam. It's important to note that the concept of quantum foam realities is still a speculative idea and remains an active area of research and theoretical exploration. Direct observational evidence for the existence of the quantum foam, or its influence on the nature of reality, is currently limited. Simulated universe hypothesis. The simulated universe hypothesis is a speculative concept that suggests our universe could be a complex computer simulation created by an advanced civilization or beings existing in a higher dimensional reality. This idea draws inspiration from advancements in computer science, virtual reality, and the potential capabilities of future civilizations. According to the simulated universe hypothesis, the physical reality we perceive, including the laws of physics, the emergence of galaxies, stars, and even conscious beings, could all be part of an intricately designed simulation. It proposes that the universe we experience is not fundamentally real, but rather a highly sophisticated simulation running on advanced computational machinery. Proponents of this hypothesis argue that if sufficiently advanced civilizations in the future could develop technology capable of creating such simulations, then it becomes statistically likely that we are living within one of those simulations. They suggest that our reality could be an artificial construct designed for various purposes, such as scientific exploration, entertainment, or even the study of the origins of the simulating civilization. It's important to note that the simulated universe hypothesis is highly speculative and falls within the realm of philosophy and theoretical speculation rather than empirical science. While it has gained attention and discussion in popular culture, including books, movies, and scientific debates, there is currently no empirical evidence to support or refute the idea. Critics of the hypothesis raise various objections, including the difficulty in creating a simulation complex enough to encompass all the detailed observations and interactions we observe in the universe. Additionally, the question of how consciousness and subjective experiences arise within a simulated reality remains a significant challenge to address. Cosmic cycles. The concept of cosmic cycles proposes that our universe undergoes a recurring pattern of expansions and contractions, leading to the formation of new universes in a cyclic process. This idea suggests that the universe we currently observe is just one phase of an ongoing cycle, and there have been and will be other universes before and after ours. The notion of cosmic cycles has been explored in various cosmological models, such as the cyclic model and the oscillating universe model. These models propose that the universe goes through a sequence of expansion and contraction phases, where each cycle starts with a Big Bang event, followed by an expansion phase, a period of cosmic evolution, and ultimately a contraction phase leading to a big crunch or collapse. During the expansion phase, the universe expands, cools, and allows for the formation of structures such as galaxies, stars, and planets. Over time, galaxies may merge, stars exhaust their fuel, and the universe gradually enters a state of lower energy and decreased matter density. Eventually, the contraction phase begins, where gravity causes the universe to collapse inward, leading to a highly compact and dense state. In the cyclic models, the contraction phase does not necessarily result in a complete annihilation of the universe, but rather leads to a transition to a new expansion phase. This cycle of expansion, contraction, and subsequent expansion repeats indefinitely, creating a sequence of universes that may have different physical properties or follow slightly varied laws of physics. It's important to note that while the concept of cosmic cycles is intriguing, there is currently no direct observational evidence to confirm the occurrence of such cycles or the existence of previous or future universes. These models rely on mathematical and theoretical frameworks to explain the behavior of the universe at a cosmological scale. Researchers continue to explore the possibility of cosmic cycles and investigate the potential implications of such models on our understanding of the universe's origin and ultimate fate. Scientific literature and cosmology research papers can provide more in-depth information on the theoretical aspects, mathematical formulations, and current debates surrounding the concept of cosmic cycles. Consciousness-driven realities. The concept of consciousness-driven realities proposes that beyond the observable universe, there may exist realms or dimensions influenced by consciousness. It suggests that consciousness plays a fundamental role in shaping the nature of reality, and that the universe we perceive is a product of conscious observation and interaction. This idea stems from the philosophical question of the relationship between consciousness and reality. While the scientific understanding of consciousness is still a topic of ongoing research and debate, some theories suggest that consciousness may have a deeper connection to the fabric of the universe than previously assumed. According to this perspective, consciousness is not merely a byproduct of physical processes, but an integral part of the cosmos. It speculates that there might be realms or planes of existence where consciousness holds a more prominent role, influencing the laws of physics and the nature of reality itself. In consciousness-driven realities, the subjective experiences, intentions, and observations of conscious beings are believed to shape and mold the world around them. This idea suggests that different states of consciousness could lead to different realities, each with its own set of rules and manifestations. While this concept falls within the realm of speculation and philosophical exploration, it has captured the attention of thinkers, researchers, and spiritual traditions seeking to understand the nature of consciousness and its relationship to the universe. It raises profound questions about the nature of reality, the interplay between subjective experience and objective existence, and the potential for conscious beings to influence and co-create their realities. Thanks for watching. If you enjoyed what you saw, don't forget to hit like button and subscribe to my channel for more captivating content.